Good morning, CNC students. Today we're going to talk about our MT200 class, multi-axis machining and programming. And we want to talk today about how to set our work coordinates in a 5-axis mill. The mill we have here is a VF2 super speed with a 5-axis trunnion mounted to it. And this creates some unique challenges to setting work coordinates. So we want to take a piece of material like this and set a set of work coordinates and end up making a part like this. The problem with the traditional way we set work coordinates is as we pick one point and our part rotates to cut, that X, Y, and Z coordinate is also moving. So how do we control that? Well, the way we're going to do it in our CNC machines is we're going to program everything off of the center of rotation. And the center of rotation on our machine is going to be the center of our 5-axis trunnion table and also the center of rotation in Z, which is going to be the difficult part to pick up, from where this trunnion rotates around. So practically, how do we do that? So the first thing we have to know and do is we have to know that our trunnion table is flat. If we don't start with a flat table, all of our readings are going to be off because everything will be tilted on an angle. So we're going to put an indicator in our machine. And we're going to take that indicator and we're going to run it across our table, and we're going to make sure that our table is laid perfectly flat. Once our table is flat, we can set our A-axis work coordinate. So normal way you set work coordinates, we're going to go to our offset page. We get our offsets there, pick the offset we want, which in this case we can use G54. And we're going to move over to our A-axis offset and hit part 0 set. That'll set our A-axis flat. Once our A-axis has been set flat, we're going to pick up the center of our table because that's the point that our trunnion rotates around. So our part, as it sits on the table, is going to rotate on our table. And it doesn't matter if it's off center or right on center, either one. So we're going to use our coaxial indicator. We're going to move it into position just like we would on a 3-axis mill. And we're going to use that to sweep the center of our rotation of our table. Because it's the center of a bore, that gives us both our X and our Y G54 work coordinate, and it's the center of rotation of our table. So once we've swept that point and we're sure that it's correct, we're going to set our work offsets for G54. So here's our work offsets. We're going to set our X in our Y table. And we already know what that is because this table's already been swept. Pretty simple process to this point, right? Make sure our table's flat, sweep the center of our trunnion, and that trunnion table will give us the center of rotation and give us the X and Y coordinate. Now the part that's more difficult is picking up our Z-axis. Let's remove our indicator and I'll show you why. So a lot of people will make the assumption, incorrectly, that the center of rotation of our table is going to be on the top of our table. And actually that's not correct. The center of rotation is on the center line between these two bearings on each end of our trunnion. So as our table sweeps, up and down in our B-axis, the center of rotation is actually off of the top of the table. So we need to find that point. What's the difference between the center of those bearings and the top of our table? And here's how we do that.
now.
So, we're gonna take our table. Now we know what zero is in B. And we're going to stand our table up vertically at 90 degrees. We'll use an edge finder to come down and edge find this this would be a positive 90 degree setting. We'll find that distance from the center out. And then we'll rotate that table back to a negative 90 degrees. And we'll use our edge finder to find that edge. And what we're measuring is the difference. The difference when it's at this angle, we measure there. Then it rotates to this angle, and we measure there. We're measuring the gap between those two. That gap tells us when we're back at zero how far the table is from the center of those bearings. Once we have that number, we can use that number like we set a tool offset, and we're going to set a Z height for our G54. In our 5-axis machine, we set all of our tool heights to this side of the trunnion. So to find our Z height, we're going to measure from this height to our tabletop when we're at zero, and we're going to add that shift amount. That's going to give us a height from this block down to our center of rotation. Just like we set our G54 X, Y, and A axis, we're also going to set our Z axis height. And in this machine, we already know that Z height is about a negative 3.711 inches from that height. Now when we program our machine, we're going to program our machine as our material is at the center of rotation. So every time that rotates on that center, we'll know exactly where our part material is stationed. With that information, we can put that in Mastercam, and we can use our software to calculate all the points. Hope this was helpful. Stay tuned, more videos to come. Thanks.